So whenever we cut the cylinder in the different orientations, see how we have cut. We have taken the cylinder from the axis throughout, right? And we are trying to view the front view. So what we get in this case, a rectangle we see. Okay. Now, if we cut the cylinder in this direction, parallel to the base, and what we see it in the top view, a circle. Correct. Now, if we cut the cylinder oblong like this, correct. So let us check what we see in the front view and what is seen in the top view. Still, we see a circle in the top view, right? Let's see what we see it in the front view. See, front view will be like this. Okay. So we see the some part of the cylinder, and here we see it. Able to visualize what we get? See, this is a front view that we get whenever the cut section of a cylinder is taken.
Sir,
Yes, bolo.
I can only see the meat screen. I cannot see the AutoCAD screen.
So you cannot see the screen of solids. Another one. Okay, we'll share with a different angle. Let's see with the entire. Let's see what we get. Now, hello.
Yes, now I can see.
Okay, so I shifted to the entire screen. See, this is a cylinder I was showing. The cylinder is cut. Let us say cylinder is cut it like this, and what we see it in the front view and the top view. This is the top view. We see a circle, correct? And what we see in the front view, see a rectangle, correct? This is the rectangle we see in the front view. Again, shift back to the original view, and let us again take the section. But now we take the section in such a way that cutting plane is now inclined at some angle with respect to the horizontal, right? Can you see this cutting plane? This is the cutting plane with making a certain angle with the horizontal. So now what is we see it in the front view and side view. Okay. So let us look at the top view. Top view we say look it as a circle, right? And now what we see it in the front view. See what we see it in the front view. In the front view, we see some part of the base of the see. We see the cylinder's rectangle. That is whenever we see it in the front direction, we see the rectangle. And because of this cutting plane being inclined, we see the ellipse because cutting section is inclined. In this way, we will proceed for different parts. Okay. So now go back to the PPT. So the cut section or the cut surface is called a section, and actual shape of a section is known as true shape. Now, how do we see the actual shape? So this to go to the actual shape, we will need to look it in the direction in which the cutting plane is taken. So to see the actual shape, we need to look in the direction perpendicular to the cutting plane, direct in this direction. Okay, then only we can see the true shape of the section. Otherwise, whenever the such a section is taken, either we see look it from the top or either we look it from the front or the side. What we see, it's a reduced size of the object, and this is actually the true shape of the object. Okay, this is true shape whenever we see in the direction perpendicular to the plane. Getting this? Hello.
Yes.
Okay,
Yes, sir.
so let's So how we are going to cut this object? Cutting could be obtained by horizontal plane. Cutting plane is obtained by vertical. Cutting could be obtained by auxiliary incline, that is inclined to the horizontal plane. Cutting plane could be obtained by auxiliary vertical plane, that is inclining to the VP. This is inclined to the horizontal, this is inclined to the vertical. And this is horizontal plane means it is perpendicular to the vertical plane and parallel to horizontal. Cutting plane is obtained by vertical plane means it is vertical, so it is perpendicular to horizontal plane. Okay, and this is profile plane means it is perpendicular to horizontal as well as uh, vertical. We generally don't do the cutting by profiling planes. So these are all these different section planes. I will go further. I will explain with example. Hatching of section. Whenever the cut section is shown, right? So we show the hatching. How do we show the hatching? I will tell you. Okay. See, this is the first question. Let us say you can see this is a, we can say, a square pyramid. Square pyramid has a section taken. This is a section line, right? And in this case, section plane you can observe here is, in this case, is horizontal section plane, right? What do you mean by horizontal section plane? Cutting plane is parallel to horizontal plane and perpendicular to the vertical plane, correct? You can see because of this plane, we see a cutting plane line or section plane in vertical plane, right? And this is a retained portion of the object. This is retained portion. That is, here it is 1 dash 2 dash to A dash B dash C dash D dash to 3 dash 4 dash. This is the retained portion of the solid. Whereas from O dash to 1 dash 2 dash to 3 dash 4 dash is removed. And that's why we see a section shown here. How do we draw a section? From this vertical line we draw here, which is cutting the edge 1 dash 2 dash, sorry, it is cutting the O dash A dash and O dash B dash, O dash A dash and O dash B dash at 1 and 2 respectively. Similarly, we draw a vertical line here in this way, which is cutting the O dash C dash and O dash D dash at 3 and 4. I will show you, then it will be more clearer to you. So this is a front view we get, and this is a sectional top view we do get. Okay. Now that was a horizontal plane. And now this is a vertical section plane. In this vertical section plane, we can see the plane is vertical. So it is perpendicular to horizontal reference plane, correct? Or horizontal plane. Say in this case, the cylinder is cut. After the cutting the cylinder, it is not cutting throughout. It is some part of the cylinder is getting cut. So what we see, look at this. I will show it in the SolidWorks. So we want to cut the cylinder. See this. After cutting this cylinder, what we see in the front view, see this. Edges of the cylinder is visible, correct? And we see that this is the retained portion of the cylinder, whereas this much portion gets removed. Okay. So we will be showing the cylinders like this after cutting it in the vertical plane. How you have cut? It is taken vertically. Now in the same plane, same way, if we take the inclined vertical section plane, right? In this case, the section plane is inclined to the vertical plane and it is perpendicular to the horizontal plane. Look at this. This is a section plane, okay, which is making inclination with respect to VP, where it is perpendicular to horizontal plane. If we take that, okay, this is a cylinder. I'm taking the cut. Yes. Okay. So this is a cut we have taken. In this case, can you observe after the cutting, what we see? So how does the cylinder is looking now? After the cutting of the cylinder with the help of cutting plane. In this way, we will cut. Now, whenever the cutting plane is horizontal, so cylinder is cut with the help of horizontal plane. What we see it in the top view? We see it in the top view is a circle. Can you observe this circle? This cylinder is placed vertically and we cut with the horizontal like this. So we see it in the top view is a circle. And now if the cutting plane is inclined with the respect to the horizontal, still we will be able to see the circle in the top view. But same case, if the cutting plane is instead of inclining the with respect to the horizontal plane, inclined with respect to the vertical plane, we will see this rectangle like thing in the front view. Are you getting this? Hello? Are you
Yes,
there?
sir.
Oh, okay.
Yes, sir.
We skip this. Uh, One point is to be remembered. If you are cutting the cylinder cone, right? So the points of intersection that we are going to have will be lines which will be needed to be drawn by curves. Whereas in case of the cutting the solid with respect to the points of intersection, we will be getting the straight lines for pyramids and prisms and cube. Okay, remember that. So how do we get the true shape? True shape is to be drawn whenever we looking in the direction of normal. Okay. For polyhedra solid, the true shape of section depends upon the number of points of intersection, and the shape of the section will be polygon, having a side equal to the number of points of intersection. Now, what do you mean by the number of points of intersection? I will tell you. Let us take this example. A cube, 40 mm side, is cut by horizontal section plane at a distance of 15 mm from the top. For such case, we have to draw a sectional top view and sectional front view. So very simple question, but I will show it on AutoCAD so you will understand how to draw. Are you able to see the screen of AutoCAD?
Yes, sir.
Okay, let's draw a horizontal line. Auto mode on. right? So for a cube, it will be observed as a square, correct? So we'll draw it as a square, right? So 40 tab 40. Okay, this is a square we draw, right? Now what we will be observing it as a top view. Top view will also be the square. At certain suitable distance, we will mark it, right? Here we touch it to the xy, but top view will not touch to the xy. Okay? So we draw the projections like this. This will be 40. This will be 40. This will be 40. We will give it the annotations as per our. Right? So we will give it as a dash, b dash, c dash, d dash. Okay, and then we can move it. Then what we'll have to do, we have given the position of the cutting plane, right? So in this case, the cutting plane is at a distance 15 mm from the top. So what we will do, we will take a line from here. We will take a 15 mm, right? And we will draw one horizontal line like this. Okay. We will stretch it on the other side. Okay. We will select this line and we will make this line as center line. As I am not using a template, I will have to load the center line from the line types. Okay. So this will not be your requirement to select the line from the line types. You will be just getting it in the template. Template will already have that type of line. Center line. Okay. My line thickness should be 0.09 unless I am very much sure. Right. So this is my initial, we can say, setup. So now after the cutting is done here, right? You can see that this plane is cutting the solid at the two faces. One is on the left side and one is on the right side. But as far as the cube is concerned, what are the specialities of the cube? I will show it on the SolidWorks. Then you will understand. How many edges the cube will cut? Technically, see, this 40 is the side. This is also 40. Okay, this is a cube, correct? So after cutting this cube, see this cube is cut. Okay, this cube is cut with the help of horizontal plane. Can you see this? This is the distance of a cube which is getting cut. Correct. So now you can really observe that this cube is getting cut at the how many faces? Look at this. This is front. This is back. This is front and back. So this cube is getting cut at the 4 different places, right? So still, so even if we have drawn here is A dash B dash, this cube is actually cut at the this front side as well as back side. Here also, the cube is getting cut at the front side and the back side. So what we see in the top view, this much portion is retained and which portion is removed, that we have to show. See, for a cube, this is the portion of the cube is retained, right? And this much portion of the cube gets removed. So the retained portion of the cube, we will have to section it. Okay. So for that, we will be using a this command, which is called as hatch, right? Then we will have to select a pattern ANSI 31 and we'll select the object in this way, right? Now, if you closely look at this command, it will ask you to either select the object or pick an internal point. If the object is very simpler, it is better to have a pick internal point option instead of the selecting the object. I will show you the difference. I am deleting this. Okay, selecting this command again, right? Now I'm going to the pick internal point, right? And I will select the inside portion. You can see hatching is done at one stroke, right? Because the object was simpler. In this case, you get the this is a sectional top view and this is a front view of a object. Is it okay? Is it clear?
Yes, sir.
Okay. Such question will not be asked in exam. Just for reference, I have it. Okay, you can see the nomenclature. ABCD for the base and A1, B1, C1, D1 for the top. You can continue these or you can give the both the top and base same names. Yes. Let us look at this question. A pentagonal prism, 30 mm side of base, 50 mm axis, is standing on HP on its base, whose one side is perpendicular to VP. It is cut by a section plane, 45-degree inclined to the horizontal plane. Through the midpoint of the axis, draw the front view, sectional top view, sectional side view. Also draw the true shape of the section. Now, as far as the SU23 pattern is concerned, they do not have the sectional side view, right? And they even may not be asked with the true shape of the section. They will just have to draw the front view and top view and the development. Okay, but for a 2020 pattern, that is for Chirayu and uh, Arpita, you will have to go through all this. Then only it will be a question of 20 marks. Okay, so I'm copying this question. To read the question very carefully, what we see in this question, cutting plane is given, right? What type of solid is given? That also you need to be confirming first. It's a pentagonal prism, right? What is the peculiarities of prism? Bottom and top will be same, right? For a prism, correct? So if I show it in the SolidWorks, right? This is the pentagon we have drawn, right? What is the side of pentagon mentioned in this case? 30 mm, right? What is the axis side? 50 mm in this case, right? This is a pentagon prism. So we can see here, this is a top base and this will be a bottom base, which is shown here somehow. Okay. If I show it through the hidden lines, you can see it. So this is a top base and this will be a bottom base. Okay. Able to see?
Yes, sir.
Okay. So now if we cut this, right, with the help of cutting plane, right? So we will be seeing a different shape solid that we will have to draw, right? Now based on the orientation, the solid may be cutting the cylinder, cutting this prism like this, okay? Or solid may be cutting the prism like this, okay? See this retained portion. This is one type of cutting plane, in which case the cutting plane is vertical, right? In this case, the cutting plane is inclined to the horizontal plane, right? And the another one will be cutting plane is inclined to the vertical plane, okay? So in this case, we will get the three different answers based on the how we are taking the cutting plane. So let's draw, okay? What is given? Prism 30 mm side of base, 50 mm axis standing on HP on its base. Now, how we have to orient whose one side is perpendicular to the VP, correct? So for this case, we will take the XY line first, right? Then we take the polygon, number of sides 5, right? We select the edge, right? Then as the one of the side is perpendicular to VP, either we will draw it like this or like this. This should be the only case. Either orient the pentagon like this or like this. Let us we draw it like this. The side is 30 mm. Okay. So now we give the names. So as it is below the XY, we give the names A, B, C, D, E. Okay. Then explode. This is B, C. So initial portion will be very much similar to the projection of solids, right? Okay. Then we give the names A dash, comma, B dash, then C dash, comma, E dash, then D dash. This is for the projection that we are going to get in the front view, correct? Now we project this ortho mode on, right? This is the projection we take it till the XY line, and this is the projection for D. Now for axis, look at this. select the edge and we see the center is getting highlighted. Now it might happen that the geometric center may not get highlighted. So for us to highlight it, get it highlighted, go to the OSNAP settings here, where you can see the triangle. Right here, geometric center option should be check marked. Then only it will get highlighted. Otherwise, you may end up with the wrong height of the or the wrong place through which the axis will be drawn. Right? Only through this mode only you will have to go for the selection of the axis. That is through the geometric center. From this XY plane, we select the 50. Right? Then from these different edges, we select the 50. Right? And then from this, then we join. Okay? We will select this edge. We will change the line type to center. Okay. Now, even though I make it center, you can see that the center line does not appear. So what is the command that you have to use? LT scale, so that the distance between the shorter line and the larger line gets separated or increased or decreased based on the requirement. I'm changing the scale factor to 0.5. See this. Okay. Can you see this? Now center line is looking like a center line, otherwise it was looking like a continuous line. If you feel that this is also not enough, you can further reduce. I make it a 0.3 series center line. Okay. So once it is done, you can proceed for the annotations. So this is A dash B dash, this is C dash E dash, and this is D dash. Same names I will copy. If you are not comfortable with the same names, you can write down A1 dash, B1 dash for top. Similarly for C1 dash, E1 dash, D1 dash for top, and without one for the bottom. I prefer to keep the same. Okay, this is done. Don't do thickening of the edges for the front as well as top before the section plane is positioned. Okay, what is mentioned now? It is cut by a section plane 45-degree inclined to the horizontal plane through the mid axis. So this is the axis. So how do we get the midpoint of the axis? See, this is the midpoint we get. Ortho mode needs to be on, right? So for this, we extend it the line. We select this line. We will make it the center line, right? So we have taken an axis which is passing through the midpoint. Now we have to make it the cutting plane inclined to the horizontal plane. So select this line, go to the rotate command, and what is the base point we should keep? Base point we should keep is the intersection of this horizontal line, which is cutting plane line, and this axis. So this point we will keep it as the base point. And now by what angle we should be making it inclined? 45. So we type 45 like this. Okay, I will zoom it so that you will see clearly. See this. After zooming in, now you can show the retain portion. See, further I will zoom. Look at this. Only I am now highlighting the front view. So retaining portion or retain portion, we will have to make it darker like this. Okay, you can see it is very close. It is not getting exactly through the corner of the top. Okay, this also we will highlight, which is the retain portion of the edge. Okay, and then we can name these points. Now from this edge, we will draw a vertical line like this. Trim this portion. Okay. So now, what this cutting plane shows? This cutting plane line shows that this much is the portion of the prism is getting cut, and this much is the portion which is retained, right? So for the retained portion, we will have to draw a section. You can see that it is almost cutting the entire portion of the prism. Only this much portion is not getting section. So from this point, I have drawn one vertical line, right, which is intersecting here, the base of the prism at two places. So what we will have to do now to draw the sectional top view, select this hatch command, right? Then select the internal point like this and enter. Okay. Now you can select the edge and now make a thick. This way the sectional top view gets complete. Okay. Getting this? Hello.
Yes, sir.
Okay, because it is almost cutting entirely. Now, if you miss this much portion, still it could be okay. I will not say it is okay, could be, because if you find out what is the distance between these two, it's almost less than 1 mm. Say this 0.52. Okay, so in the print, it might be very close or it might not be at all visible. Okay, you draw, try to get it perfectly, but if you don't get, it's still okay. Now, how to draw the true shape of the section? For that, we will name this the points where the cutting plane line cuts the front view. Okay, there are multiple ways how you can give the names. I give the names based on the which edge they are cutting. So P, A, comma B, or A dash, comma B dash, P, C dash, comma E dash, right? And P, let us say it's 1, 2, 1 dash, comma 2 dash. This is not the unique way to give the names. Okay. Okay. So now explode. So now you can see that this cutting plane is cutting the two edges. One is at A, one is at B. That's why I've given the name PAB. Now I'm moving this. For that, we select this entirely and then we will have to move. So this is point P A dash, comma B dash. Then this is P C dash, comma D dash, and this is P. I am switching off the O snap because those 2 points are very close. Say this, right? So this point will be PA along with A. This point will be PB. This point will be PC along with C, and this point will be PE along with E. And where is now P12? See, this point will be P1, this point will be P2. In this way, we can give the names. Okay. I will just show the P1 and P2 here. P1 and P2. Move. This is suppose P1 and this point is suppose P2. Okay, both are very close to the D, so it is very difficult to exactly identify here. Only while zooming you will get to know. This point is P1 and this point is P2. Now how to draw the true shape of section? Select this edge, select the annotations, this, select the this line, select this projection line and this also. Okay. Now what we will have to do? We will have to copy this, right? Select this snap point of the XY line, right? And keep the ortho mode on and place it at suitable distance. While placing, you may have to switch off the snap, right? And then you place it and click. Okay, done. Now select entirely everything, right? Then click on the rotate. What was the angle which is made by this line? 45 degree, correct? So now you wanted to make it horizontal, correct? So what we will have to do? We will select the one of the point here. Let us select this point, and to make it horizontal, we will rotate by minus 45. Okay, like this. Okay, getting this, what we have done earlier was the angle 45 degrees. Now you will have to do the reverse. This is 45. Now from this each each important point, that is P A dash B dash, P C dash E dash, and P1 comma 2 dash, we draw projection line like this. Okay, right? Similarly from P C dash E dash, we will draw this, and then from this P1 2. Okay, once these lines are drawn, delete this projections because these projections are not required. Okay, now we will intersect this projection line with this PA. Okay, so this point we are getting is the PA point. Similarly, this PB will getting intersect with the projection obtained from B. Right, now we take a projection from C to get the point PC. Okay, then we intersect this E to get the projection PE. Now we will have to zoom in. So from this we get the point P1. Okay, again we zoom. From this point we get the P2. Okay, so I copy this P1. So this point is P1. Copy this. This point is P2. Okay, similarly other points also we can write it down. PA, PB, PC, PE. Okay, give the subscript to the C, give the subscript to the B, give the subscript to the A. Right, then we can move in. So this point is this is the point is our PA. Right, moving this PB. This point is PB. Moving this point is PC. This point is here is PE. Are getting these points? Intersection of PA dash B dash with A, this PA, PA dash B dash with B, PB, PC dash C dash with E is PE, right? And PC dash with this projection is PC, and similarly P1, P2 intersection with P dash 1 dash. Now this intersection we will have to join to get the true shape of the section, right? There are two ways to draw the projections or to get the true shape, but I find this method is comparatively easy. Okay, once this is done, we will have to draw the section, right? In this case, we select the internal point. Okay, so when if we select the internal point or they select the edge, we will have to do it 5 times to get the entire this we can say true shape getting section. Okay, so this is a sectional, sorry, this is a front view, right? This is the sectional top view. This is a true shape of the section. What is still remaining is the sectional side view, right? So for the sectional side view, you may have to extend it on the left side, or you may extend this moving further like this. You may have to do it in this way, right? And then you can stretch it. For the sectional side view, we will have to draw one vertical line like this. Okay. Then from here, this besides this ortho, you will see this tracking mode or polar tracking mode, right? From this, you take a 45-degree line. You can see the different angles are here. So we get 45, 90. Just select this point and you can see it will automatically will guide you to draw a line of 45-degree angle. See this. Okay. Once it is done, we have already taken the projections. So from each projection, you just draw the line. So this is the projection first. So it extending till here, right? Then we take the projection from A. Then we take the projection from B. We take the projection from C, right? Then projection from D is remaining. So we will extend it. This is the projection from D. Okay, in this way. And then you just draw one horizontal line from here. So this is your side view. Okay. So in the side view, we will name the side view. How we can give the names for the side view? We may give the names as same. Just increase one dash, right? So we will call this as this is the edge of E. So we'll call this as E double dash, and this will be E double dash. Okay. I will show you A double dash, then B double dash, C double dash, D double dash, E double dash. See this, which is the edge? This is A double dash, right? Then where is B double dash? You can see that this is the B's edge, so this will be B double dash. Where is the C's edge? This is C. Okay, so C is on the moving on the right side. So this will be C double dash. Okay, where is D? D is at the central portion. So this will be D double dash. Okay, where is the E? E is moved on the left, right? So this is the edge of E double dash. Correct. Same names will copy for the bottom of the side view in this way. Okay. So now to complete it, side view, we will have to draw a horizontal line from the important points on the front view. So this we will draw. So this is the point where the A edge is getting cut, and this is the point where B is getting cut. I'm not extending full, right? This is the important point A dash, and this is the important point B dash. Similarly, say this. Which edge is getting cut? C dash, E dash. So from this front view, where is the C, E dash? This is the point E dash. This is the point C dash. Correct? Now, is there any important edge left? No. Directly base is getting cut. Right? So now, how to name? Here we have given the names as P A dash B dash. So we can give the names as P A double dash comma B double dash. Names are not important. You just locating the important point is critical. Right? Similarly, P C double dash comma E double dash. Okay. Right? Then P1 double dash comma 2 double dash. Increasing the height 5 and then explode. Look at this. Oh, this is the point PA, right? And this should be the point PB. And this should be the point PB. So we'll have to edit it here. First, I will move this point, copy. This is the point we are getting is the PA dash. This point. And this is the point we are getting is a PB dash. Getting this? Hello?
Yes, sir. Understood.
Okay. Copying this. Okay. While copying, you will have to select C and E together. Then only you can get copy. So this is the point. Where is the C? C is on the outer edge. So this is C. This is E. Okay. This is P E dash. Moving closer. Okay. Whereas this is for only C dash. Right. And now P1 dash and 2 dash are very close to each other. First, I will move this. Copy. O snap is switched off. 1 dash here. On the right side is 1 dash. P1 dash. On the left side is P2 dash. Okay. Here. So I am taking the points from this. This is for 2, right? And then this is for 1. Okay. Now what we will have to do, I'm changing the line thickness, joining in a sequence. This is the point P dash A dash. I am able to see this is a PB, PC, P1, P2, PE, PA. Okay. Now you may have a question why I have shown like this. Now if you want to draw the side view, we will be looking in this direction, right? We will be clearly able to see this PAB point, PCE point, and this top base, right? So that's why we have drawn it like this. Now the outer edge that we will have to make it dark like this. This is the retained portion. Okay. Now see this. This is the edge which is uncut. So here in the side view, this is the edge will have to be shown as uncut of the prism. Similarly here, this is the edge remaining uncut. Now, as we will show it in the sectional view, the DD edge, if you look at from this end, which is the edge of the prism, won't be able to see. We will have to draw it hidden line. But generally we don't draw a section. So that's why we will skip that. Okay, so we will select the edges. Okay, done. Generally we don't keep the thick lines for the section lines. So that's why I'm changing the line in this way. Okay, so this problem is done. Any doubts over this?
No,
Hello.
sir.
Okay, okay. So I'm sharing the video and this question to you along with the answer and the PPT. Okay. So